If you look at this graph right here, these are going to be approximations. There's a little bit of leeway in where you plot the points, but the idea is you're using the closed point if it's included, the open point if it's excluded. So here, when you look at negative 9/5, negative 9/5 is just under what value? It's almost to a negative 2, right? So what we can do is we can plot that. Is it going to be open or closed? Open. So we'll put it just under negative 2. And then 31/5 is closest to what integer? 6, just above 6, right? And is it going to be open or closed based on this grouping symbol? Parentheses means open, so we'll put that point here. So what you're going to do first is you'll plot your 2 points, and then you're going to choose this draw tab. When you choose the draw tab, you'll then draw between these two, and if you pick between 2 points, it will just create a segment, and so it'll end right here. Okay, if you do the same thing down here, you have a negative 2 as your lower limit. It is less than or equal to, so, or in this case, x is greater than or equal to, so it's an inclusive. So you'll put a close point. And then root 53. Root 53 is between what two perfect square roots? Perfect powers of, or perfect squares would be 49 and 64, right? 53 is somewhere between that. So what is the square root of 49? Square root of 64. 8. So you know it's going to be somewhere in between 7 and 8. And you can kind of gauge it. Is 53 closer to 49 or 64? Probably a little closer to 49, right? So if you make when you place your dot, place it a little bit closer to the 7. And because this is a less than here, there's no equal to, I'd click the draw tool, and I would draw my segment between those two. Okay. Now, when you're working with the unbounded intervals, what you're going to do is you're going to plot your one single critical point. So 6/5 is where? Just past 1, right? So it's 5 or it's 1 and 1/5. So it's just going to be just past the 1. And is it open or closed? Has the equal to, so it's closed. So if I plot this point, and I want all my x's to be greater than or equal to this. So now when I click on this draw tool, what I'm going to do is draw from here, and I'm just going to go all the way. And once I get to the end of this, it should change it to an arrowhead. And it'll just change automatically, and that's how you can indicate that it continues. Okay, with this example down here, you have a negative 3.8, so again, you can plot that. Is it going to be open or closed circle? It has the bracket, so it's a closed dot, pretty close to negative 4, and we're going to the left, and so once again, when I hit this draw tool, I'll extend it out, and once I get to this point, it will put an arrowhead on it. So let me kind of show what that actually looks like with an example. Right. So if this was my example here, I'm dealing with this bounded interval. So what I can do, I know my lower limit and my upper limit are both going to be open dots. So I'll select open dot. Negative 23/5 is just past what number? Or it's almost to what number? You can think of it either way. It's almost to negative 5. So I'm just going to put a dot somewhere around negative 5, somewhere between negative 4 and negative 5. And then my upper limit is 3, so I'm going to go ahead and put a dot, open dot at 3. So here's the first steps. I'm then going to select my draw tool, and I'm going to draw a line between those two. And when I confirm this, I see that it gives me credit for that. Again, it's approximation, so there's a little bit of leeway. So what if this was the sketch? So here, my upper limit is 1.4. It has a bracket, so it's included. So I'll plot somewhere around 1.4. Again, it's an approximation. There's no other dots here. I'm opening now to the left, everything below this. So I'll select my draw tool. And when I draw here, notice as I get to this step, it turned into the arrow. Okay, and that is my solution. I can submit, and it confirms that I got it.